Good morning, dear students, and welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with today's session. Today's session will be based on question and answers, particularly those questions from your NCERT textbook. This is actually a session 6 of the chapter Motion in a Straight Line. So far, we've dealt with some of the physical quantities such as distance, displacement, speed, velocity, acceleration, and we classified this physical quantity under two categories known as scalars and vectors. Also, we learned how to graphically represent these physical quantity and obtain necessary information from it. And then we proceeded with deriving some of the equations of motion, particularly for those in one dimension. Now, there are three equations of motion that we derived, not just by a regular method of a graphical where you have the VT graph, and from that we arrived one of the equation, but also we derived it using calculus. And then we learned what is a relative velocity, a velocity that is observed by a different perspective, a different person. Now I want to give a little more detailed concept based on this relative velocity, how a velocity appears to be different for an observer in a different frame of reference. So let's get started with this example of a train. Two trains, namely call it train A, choose color, ink, call it train A and train B. Now train A and train B are going to displace, and when they displace, they move with a certain velocity. We're going to make sure this train travels in only one direction, which is towards your left hand side, in a straight path. So by this observation, we can come to a conclusion that it travels with a certain velocity, let's say for a train A, which is VA, and for a train B, which is VB. If any observer sitting on train A, let's say you are sitting in train A and you observe the train B. So let's see what happens when these two trains displaces. And you see, for a perspective that is outside, the two trains moved at the same time, meaning that the velocities were the same. But for you as an observer sitting inside a train, how does the train B appear to be moving? Will it be appearing to move faster or slower? Well, the answer is it will appear stationary if you are sitting inside train A. So why is that for you sitting inside train A, observing train B, appears that the train B is at rest? This is where we come to an understanding of a relative velocity. Now, velocity of object B, velocity of an object V with respect to object A. Meaning you're trying to make an observation from object A, isn't it? So velocity of object B with respect to object A is equals to VB minus VA. Now what did we initially state? That the two trains are moving at the same velocity. So if VA is equals to VB, then VB of A will be equals to 0. And this is why when you make an observation from train A, B will look as though it is stationary. Let's have a look at another example, but in this case, the two trains are moving at different velocities. Again, we have train A, train B, moving with a velocity A, moving with a velocity B. So you are making an observation from train A. For a perspective that is outside the train, we see train B is faster than train A. But for a person that is sitting inside the train, will it be moving a same speed or the same velocity for the person that is outside? Well, let's have a look at it. So VB of A, VB with respect to A, which is equals to VB minus VA, but in this case, VB is greater than VA. Since VB is greater than VA, you get VBA as a positive value, isn't it? Because VB is greater than VA, so you get a positive value. And now, if the observation instead from train A is made from train B, so an observation that is made from train B, what would be its relative speed? Velocity of train A with respect to train B. Velocity of train A with respect to train B, because now you're seated in train B, which is equals to VA minus VB. But what we know for a fact is VB is greater than VA. How? Have a look at it. Oh, you see, B train is faster than A train. Therefore, in this particular case, you get the answer, which is negative. So as a conclusion, you can say that VBA will be equals to negative VAB. They would have the same magnitude. Magnitude would be the same, meaning the values will be the same, but only thing, the difference here is the direction. Yes? All right. So now for two trains that are traveling opposite to each other, what about the relative velocity in this case? Two trains, A and B, with its respective velocity VA and VB. Now, if you might have noticed, B is traveling in a positive direction, A is traveling in a negative direction. So the velocity here in this case would be in a negative direction. So VA is negative, VB is positive. Therefore, when you make an observation, that is velocity of B with respect to A, which is equals to VB minus of VA. Usually the term we write is VB minus VA, but what we noticed here is that train A is traveling in the negative direction. Since train A is traveling in the negative direction, velocity will also be negative. Minus into minus as a sign multiplication is plus VA. So this would be the relative velocity of two objects moving in the opposite direction to each other. Moving along the same direction, we saw it was negative, but moving in an opposite direction, they become positive. So what better way to understand this concept? By an example which is given here. So let us try to determine the solution to this. This is actually your NCERT question from page number 52. Question reads, a jet airplane traveling at a speed of 500 km per hour ejects its products of combustion at a speed of 1500 km per hour. relative to the jet plane. What is the speed of the latter, meaning the speed of combustion, the products of combustion, with respect to the observer on the ground? So for your reference, if you want, you can draw a jet plane, a rough sketch of a jet plane. Okay, and there are combustion, products of combustion. So these products are ejected with 1500 km/h with respect to the jet plane. All right. The jet plane itself is moving at 500 km/h. So for an observer who is on the ground, what will be the speed of combustion? So let us make note of this. Velocity of combustion with respect to the jet plane. Okay, velocity of the combustion with respect to the jet plane is equals to velocity of combustion minus the velocity of the jet plane. Right? So velocity of the combustion is about 1500 km/h minus velocity of the jet plane is about 500 km/h. Oh, you can write the units later as well. So I'll put a bracket here. Per hour. 1500 minus 500, 1000. So we've found only a part of it, that is velocity of combustion with respect to, one moment, velocity of combustion with respect to jet plane, forgive me, is 1500. I'm so sorry. This is supposed to be, so this is, you have to be very careful in this, in considering which of the following is which. Velocity of combustion with respect to the jet plane is 1500 km/h. So how do we eliminate these type of confusion? The mistake that I just made is by writing the following that are given. Write the things that are given and then you can substitute. That would be a better idea. Velocity of the jet plane is 500 km/h. What is the velocity of a combustion? Yes. This is what you need to find. So velocity of combustion with respect to jet plane is velocity of combustion minus the velocity of jet plane. Okay. So now all you have to do is plug in the values. The value of combustion, which is 1500, value of the jet plane is 500, and then you get the value of combustion of the aircraft, velocity of the combustion of the aircraft, which roughly turns out to be 2000 km/h. Right? So once you add, you get 2000 km/h. That would be the velocity of combustion. Okay? All right. Moving ahead, moving forward, let's look into the next question. Here's another question which is again related to the same relative velocity. It says, a police van moving on a highway with a speed of 30 km/h fires a bullet at thief's car speeding away in the same direction with a speed of 190 km/h. If the muzzle speed of the bullet is 150 m/s, what relative speed does the bullet hit the thief's car? So one thing you need to look out for is these numbers. They do not have the same unit. One has a km/h, two have km/h, and one has a m/s. So the units have to need to have a common. So we will convert this km/h into m/s. So to understand this particular question, I could draw a rough sketch. So you have a police van that is chasing a thief's car. This is the thief. Police van which is moving at 30 km per hour. And the thief's car is speeding at 190 km per hour. That's too fast. Cheating. Now what does the policeman do? Fires a bullet from his car. Okay, so you have a policeman who fires a bullet. So this bullet travels at a speed of 150 meter per second. So at what velocity, what relative velocity does the bullet hit the thief's car? So for the thief, with respect to the thief, at what velocity will the bullet hit his car? So first let us convert these two. So speed of police van. Speed of police van, which is equals to 30 converted to meter per second. So conversion factor would be 5 by 18 meter per second. Meter per second. So 5 by 18, you could write it, which is 150 by 18 meter per second. Next, similarly, thief's car, which is 190 km per hour converted to meter per second. So speed of thief's car, which is equals to 190 times 5 by 18 meter per second. Okay. 0.4556 by 18 meter per second. So now that we have all of them in meter per second, next let us find the relative velocity of this bullet with respect to the policeman, which is again 150. That is no issues. Now relative velocity of the bullet with respect to the thief's car would be the combination of 150 plus 30, because the car itself, policeman itself, is moving at 30 km per hour, plus he fires a bullet which is of 150 meter per second. So therefore speed of the bullet with respect to the ground, let's put it as ground. Okay, so the observer would be you, ground, which is equals to speed of the police van, velocity of the police van, plus the velocity of the bullet. Velocity of the policeman, where is it? 150 by 18 plus 150. 150 by 18 plus 150. So try to identify, go ahead, write it in your notebook, try to identify how much would be the velocity. First I'll simplify this. Okay, I'll simplify this as 2 9 times 2 7 times 14 5 times, and then this is still divisible by 3. Shall we proceed with 3? All right, 3 times 3 3 2 times 6 and 3 5 times is 15. 25 by 3. 25 by 3 plus 150. Go ahead, try to solve. Now find the LCM, so which means you multiply the numerator and denominator by 3. So you get 25 plus 450 divided by 3. 25 plus 450 is about 475 by 3, and divided by 3 1 times 3 5 times. So you get decimal. You get a decimal. 3 1 times, and then you get 3 5 times. That's 15, 25. 8 times 0.333. So 158. We approximated to 158 meter per second. Okay, approximated to 158 meter per second. Now we have the velocity of the bullet with respect to the ground. Next, what we need is the velocity of this bullet with respect to the thief car. Thief is already traveling on 190 kilometer per hour. Bullet with respect to the ground is 158. It seems as though the bullet is never going to catch up with the thief's car. Oh no, this has been converted, isn't it? We have converted this, which is this one here. So we need to subtract 158 minus 160 by 18. So try this by yourself. I'll have a look at the numbers later. Okay, try this by yourself as well. So you have 158 minus 650 by 18. First simplify these. Okay, simplify these. So cancel by 2 3 times, 2 times 4, 5 times 10, 9 times, and you can still proceed with 3. So try doing your best here and then find what is the solution, and that will give you the answer, which is the relative velocity of bullet which hits the thief's car. Now that being said, the next question is far more interesting than this. The next question, which happens to be on a question based on average velocity. So let's have a look at the question. It says a train travels along a straight path, covers half the journey with a velocity of 25 meter per second. Second half journey with a velocity of 30 meter per second. Find the average velocity of the train. First half journey. So let's draw that as a picture. You have a train, a choo-choo train. Okay, covers first half journey, let's say A to B, with a velocity V which is equals to 25 meter per second. And then from B to C, the next half journey it covers with the velocity of 30 meter per second. What will be its average velocity from A to C? Now, you may be thinking that why not just take the average as 25 plus 30 divided by 2. No, don't do that. Because velocity here is a derived quantity. The fundamental quantities used in velocity are displacement and time. So you may take the average for a fundamental quantity, but not for a derived quantity. So how do we solve this? Now, remember the total distance, we will assume it to be D. He covers half the distance, so half the distance would be D by 2. So what will be the distance from A to B? Distance from A to B will be D by 2. So velocity from A to B equals to D by 2 divided by time taken from A to B. I'm going to identify the time. Time taken from A to B is equals to D by 2 times 25, which is D by 50. Okay. Next, similarly, B to C. Velocity, that's from B to C, is again D by 2 divided by time taken from B to C. Going to the next page. Time taken from B to C equals to D by 2 times velocity of B to C. Velocity from B to C is 30, which is equals to D by 60. So can you guess what will be the total time taken? Total time taken is time taken from A to B plus time taken from B to C. What is the total distance? Total distance is equals to D. And what is the definition for average velocity? Total distance by total time. Average velocity equals to total distance D by total time TAB plus TBC. What's TAB? D by 50. Plus what is TBC? D by 60. Now we need to identify the LCM between the two, D by 50, D by 60. So find the LCM for 5 and 6. 5 and 6 LCM is 30. But now you have 50 and 60, so now you can guess what would be the LCM. So in this case, 300, if at all you were doubting. So here in this case, for this to be 300, I multiply by 6. For this to be 300, I multiply this by 5. Yes? So I get D by 6D plus 5D divided by 300. Transpose this, you get D into 300 divided by 11D. D and D gets cancelled anyways. And what you're left with is 30 by 300 divided by 11. Try to identify what is 300 by 11, and that will be the average velocity of the given object. So go ahead, try using your calculator. You're allowed to use your calculator now because now you have entered your college life. So yes, so you can divide, which is 300 by 11. Use the calculator and do tell me what is the answer. All right, so let's see, 2 times, and then you have remainder which is of 8, right? So 22, 8, 80, 80, so 80, closest would be 7, so 27, and then 80, 7, 30, then you have again 2. So 27.2 if I'm not mistaken, 27.2. So you get 27.2 meter per second. All right, so this is how you identify average velocity. Average velocity is determined by taking the fundamental quantities of total distance and total time. So don't just add up and write the solution. Now moving on to the last question for the day. This is also a question from your NCERT book, page number 52. It says, a woman starts from her home at 9 a.m., walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away, stays at the office for up to 5 p.m. and then returns home with auto at a speed of 25 km per hour. Choose suitable scales and plot xt graph of her motion. All right, so first let's illustrate this by a diagram, by a figure. So here you have a woman who starts from her home, let's say 0 meters that she's covered at the moment from her home. And what time does she start? Is 9 a.m. Okay. She is walking with a speed of 5 km per hour. Okay. Up to her office, which is 2.5 kilometers. This, let's say this is her office. Total distance 2.5 kilometer. And stays at the office up to 5 p.m. Now first, how long does it take for her to reach the office. She is walking at a speed of 5 km per hour and the distance is 2.5 km. How long does it take for her to reach the office? Very simple calculation. We have to find the time by given data, that speed equals to distance by time. Speed is 5 km per hour. Distance is 2.5 km. We have to identify time. So time equals to 2.5 divided by 5. 2.5 divided by 5 is 0.5 hours. 0.5 hours meaning 1 by 2 hours. Half hour. Half hour, 30 minutes. Alright. So 9 o'clock she starts. By 9:30 she will reach the office. Okay, remember that. 9:30 she reaches office. Then next, up to 5 p.m. she is at the office. She is not going anywhere else. Up to 5 p.m. Then what is she doing? She returns home after 5, or at 5 she returns home by auto. And auto is traveling at a speed of 25 km per hour. So from 5 o'clock when she returns home, what time will she reach home? What time will she reach home? She is traveling from office to home at a speed of 25 km per hour. So what time will she reach home? Erase this. We use the same formula once again, that speed equals to distance by time. Speed now is 25 km per hour. Distance is 2.5 km and time t is what you need to find. So you can write that t is equals to 2.5 by 25. 2.5 by 25 is so difficult. Very easy, simple. All you do is multiply the numerator by 10 and denominator by 10. By multiplying 2.5 into 10, you get 25, correct? So this 25 cancels and what you get is 1 by 10. And what is 1 by 10? 1 by 10 is 0.1, isn't it? So 1 by 10 hours. Now you have to convert this into to minutes. How many minutes? 1 hour has 60 minutes. So 60 by 10 minutes. And 60 by 10 is 6 minutes. So the time taken for her to reach home is 6 minutes. So what time will she reach home? 5 o'clock she leaves office. By 5:06 she will reach home. Alright, so now we have acquired all the following data. We have illustrated in this particular diagram. Next, what we need is to draw the graph for this. Hard? Yes, I understand it could be hard, but let's break it into steps. The first step would be traveling to the office. After that, the second step is that she is at the office until 5. And the third step is the returning from the office. So let us plot with a 2 axis, x and y axis. Along the x axis you represent it with time, and along the y axis you represent it with distance, because this plot is a xt graph in meters. Okay, quick look. 2.5 kilometer, yes. So you can start with 0.5, 1, 2, 2.5, 3. Here you mentioned kilometer, not just meter, kilometer. 3.5. Okay. time, we shall do one thing. If I have to convert it to hours, all right. So we will start with a break in the graph. 8 o'clock, 8 a.m., 9 a.m., 10 a.m., 11, 10 a.m., 11, 12. So go on, continue writing. 13, 14, 15. If you want, you can write 13, 14, 15 to represent the afternoon time, or you can also mention it by PM. So we start with 2 p.m. Okay, go ahead and write 2 p.m., 3 p.m., 4 p.m., and 5 p.m. All right. So now displacement starts at 9 a.m. and by 9:30 she reaches office. 9 a.m. she starts and reaches office by 9:30. So let's say somewhere in between, which is 9:30. So in between 9 o'clock and 10 o'clock, but if I have an actual graph paper, it would be more easy. 9 o'clock to 10 o'clock, you have 9:30. So between 9 and 10, 9:30, she reaches the office and covers a distance of 2.5. So draw a line. So this line will have a little inclination to it. And then what happens? She stays at the office until 5. So you see, she's not displacing at all. 2.5 kilometer, she remains at the office. And then she returns back home. So 5, 6. So by 5:06, she returns home. So this would technically a rough sketch of how your graph should look like. So you would have an inclination here, and then a horizontal line, and again you would have a line that is extended downwards. So this is how you can plot in a following graph. So I hope you've enjoyed the session. Do visit us at www.v-learning.in to get more details about the class. I shall see you in the next session where we discuss some more question and answers, and also try to create a bridge course for you so that we learn vector products and vector multiplication, where you have two different types of vector products. So we shall deal with this in the next session. Until then, everyone, take care and bye-bye.